Hello everyone, welcome back to my YouTube channel Cloud and AI Analytics. Hope everyone is doing good. I'm Vignesh and in this video we will continue to explore the next set of HashiCorp's Terraform Associate MCQs. And without any further delay, let's get started. So the first question of this video is you want to define multiple data disks as nested blocks inside the resource block for a virtual machine. What Terraform feature would help you to define the blocks using the values in a variable? So basically you're trying to create a compute engine inside Google Cloud Platform, and inside that particular block you wanted to create a multiple data disk as nested block. So which Terraform feature would help you to define those blocks using the values from the variables.tf file? Now we will discuss the options. The first option is local values, option B collection functions, option C dynamic blocks, and option D count arguments. Now pause the video, go through the question, understand it, go through the options, and then come up with the answer. So that's it. The right answer is option C, dynamic blocks. So dynamic blocks in Terraform allow you to dynamically generate nested blocks like data disk in this case, based on the values in a variable or even from the list as well. So this is especially useful when you need to create a multiple similar blocks based on the input variables. So the right answer is option C, dynamic blocks. Now moving on to the next question. Using the Terraform state rm command, that is basically remove command, against a resource will destroy it. Option A, true. Option B, false. Now pause the video, go through the question, understand it, and then come up with the answer. So that's it. The right answer is option B, false. So now we will understand what is this Terraform state remove will do. Basically, this command does not destroy the resource. Instead, it will remove the resource from the Terraform state file. Now, moving on to the next question, how would you refer to the indexing instance from the below configuration? You can take a look at this picture. We are trying to create a Google Compute instance and the local name is web, and we are trying to iterate it. Basically Terraform, it has value 1, resource, indexing and example. So the question is, how would you refer to the indexing instance? Basically how you will refer this value. So now we will discuss the option. Option A, Google Compute Instance Web Indexing. Option B, Google Compute Instance .web .indexing. Option C, Google Compute Instance -web indexing. Obviously from the option itself you could have understood this option is wrong. And the last option is Google Compute Instance .web and indexing. So now pause the video, go through the question, understand it, and then come up with the answer. So that's it. The right answer is option D, Google Compute Instance .web indexing. So now we will break down this particular option. Google Compute Instance .web refers to the name of the resource and basically indexing. In this way, it refers to an index or key inside an array or a map. Now moving on to the next question. Sentinel policy as a code is available in Terraform Cloud and Terraform Enterprise. We have discussed a very similar question in the previous videos. Option A, true. Option B, false. Now go through the question, understand it, and then come up with the answer. So that's it. The right answer is option A, true. Sentinel, it's basically HashiCorp's policy as a code framework, is fully supported in both Terraform Cloud and Terraform Enterprise. Now moving on to the next question. While attempting to deploy resources into your cloud provider using Terraform, you begin to see some odd behavior and experience slow responses. In order to troubleshoot, you decide to turn on Terraform debugging. Which environment variable must be configured to make Terraform logging more verbose? So this question directly indicates there is some issue with our Terraform code and we wanted to debug it. Now we will see the options. Option A, tf_log_path. Option B, tf_var_log_level. Option C, tf_log. And option D, tf_var_log_path. Pause the video, go through the question, understand it, and then come up with the answer. So that's it. The right option is option C, tf_log. So this environment variable is used to set log level for Terraform operations. You can set it to different levels of verbosity to help to debug your issues. Basically, there is trace that sets more verbose, showing all the logs. The next one is debug. It logs detailed information for debugging. And the next one is info. It shows information level logs. And the next to this is we have warn logs only that shows warnings. And finally, we have error. Basically, logs that shows errors only. Now we will discuss the other options. The option A, tf_log_path. Basically, this is used to specify the file where the logs will be written. So that is basically incorrect. And option B and option D is there is no such valid Terraform environment variable as this. So option B and D is wrong. Now moving on to the next question. Which of these is not a benefit of remote state? Option A, keeping unencrypted sensitive information off disk. Option B, easily share reusable code modules. Option C, working in a team. And option D, delegate output to other teams. So this is very easy to guess. Still, pause the video, go through the question, understand it, and then come up with the answer. So that's it. The right answer is easily share reusable code modules. Option B. So remote state offers several benefits, but sharing reusable code modules is not one of them. Remote state is primarily concerned with storing the Terraform state in a remote location, allowing for collaboration and managing your infrastructure. And also it enables several things like keeping unencrypted sensitive information off disk and working in a team and delegate output to other teams. So the correct answer to this question is option B, easily share reusable code modules. This is not the benefit of remote state, but it is the job of Terraform modules. Now we will move on to the next question. Which of the following is not considered a safe way to inject sensitive values into a Terraform cloud workspace? Option A, edit the state file directly just before running Terraform apply. Option B, set the variable value on the command line with the -var flag. And option C, write the value to a file and specify the file with the -var -file flag. And option D, store the sensitive values in a version control repository. Now pause the video, go through the question, understand it, and then come up with the answer. So that's it. Whenever you are not comfortable or whenever you don't know the correct answer while reading the question itself, you can use this approach, going through the options and then eliminating the wrong ones. So first we will discuss the option A, edit the state file directly just before running Terraform apply. This seems to be correct option because I feel like nowhere it is recommended to edit the state file manually and inject or do something before running Terraform apply. So this seems to be right option, but we will confirm it once after going through all the other options. Now option B, set the variable value on the command line with the -var. So basically this method allows you to pass sensitive value directly via the command line. Though it is not most secure, but it is also commonly used in non-sensitive context. So this seems to be not the correct option. And the next option is write the value to a file and specify the file with the -var -file flag. So basically using .tfwas file. And this is also one of the good practice in order to safely inject your sensitive values. So this option will also not be the correct one. And moving on to the last, store the sensitive values in a version control repository. Obviously, this is also the recommended way. We have to make use of this version controls like GitHub. So from all these options, we can safely fix option A, edit the state file directly just before running Terraform apply. And moving on to the next question, you created infrastructure outside of the Terraform workflow that you now want to manage using Terraform. Which commands bring the infrastructure into Terraform state? So basically from the question itself, you could easily guess the answer, but still we will go through the options. Option A, Terraform init. Option B, Terraform get. And option C, Terraform refresh, and option D, Terraform import. Now pause the video, go through the question, understand it, and then come up with the answer. So that's it. The right option is option D, Terraform import. That is used to bring existing infrastructure that was created outside of Terraform under its management. Now moving on to the next question. Which of the following should you put into the required providers block? Option A, version greater than or equal to 3.1. Option B, version greater than or equal to. This is basically inside quotes. And the next option is option C, version till greater than 3.1. And finally, option D is version greater than 3.1. So it is very easy to guess. If you go through the options itself, you will be able to finalize or figure out the right one. But still, pause the video, go through the questions, understand it, and then come up with the answer. So that's it. The right answer is option B, version, this one. So basically, except this A, C, and D, the syntax is wrong. So there is no equal to, and option B only has this equal to. So the correct answer is option B. So that's it for this video. If you have any questions, please post that in the comment section. I'll take a look at it and reply to it as soon as possible. Please do like, comment, share, and subscribe to Cloud and AI Analytics. And don't forget to click on the bell icon. I'll see you in the next video. Until then, it's bye from Vignesh. Happy learning.